Good morning, students. Today we will be discussing about the experiment in the Deca laboratory. 8x1 mux, 8x1 multiplexer. The IC number is 7x151. So we will be designing a IC 7x151 using VHDL code. So let's go with the explanation part. So this is the logic diagram, and we have the pin configuration IC, and we have the truth table. So 8x1 mux. Actually, in the theory part we have already learned what is meant by multiplexer. Multiplexer is a digital switch. It connects data from one of the n sources to its output. So we have here 8 inputs and 1 output we are having. 8 inputs and 1 output. So we are having many inputs and 1 output, but it is a line-to-line communication. That means at any point 1 input is connected to the output. Like a rotary switch, this multiplexer will be connecting 1 input at a time to the output. So we can mention this multiplexer as n input b-bit multiplexer. We can mention this multiplexer as, remember, n input b-bit multiplexer. This is what we will be defining, n input b-bit multiplexer. So n input b-bit multiplexer is nothing but n is, remember, n is source of data. N is source of data, which is nothing but a input. N is source of data, and this source of data each of with b-bit wide. Each of with b-bit wide. So here we are having 8 inputs. So source of data is 8 inputs, 1 bit wide. So here see, 8 input, 1 bit multiplexer. 8x1 multiplexer is called as a 8 input 1 bit. 8 inputs 1 bit wide. So 8 inputs we are having, each of 1 bit. Each of 1 bit. This is 74x151 multiplexer. 74x151 multiplexer. Generally, the expression for a multiplexer is like this. If you take a expression for multiplexer, generally IY j tends to 0 to n minus 1, we will be having enable input, and we will be having minterms of select lines. These are the A, B, C. We are having minterms of the select lines, and we will be having input. We will be having input. So what will be the case? What will be the case of this one? This enable will be 1, enable, and in terms of this is so A bar, B bar, C bar, and which is nothing but D naught plus enable A bar 0 0 and 1 no, B bar, C, and D1 plus enable, we will be having A bar 0 1 0, B, C bar, D2. Likewise we will be having the expression. Likewise we will be having expression. That means enable should be active. Then if you give 0 0 0, we get enable active 0 0 0. Then D0 will be presented at the output. D0 is presented at the output. So 1 to 1 mapping, I said no, this D0 will be presented at the output. D0 will be presented at the output. So this 8x1 multiplexer will be having 8 inputs. When there are 8 inputs we are having, then we will be having 8 inputs. You take, this is 2 to the power of 3 is nothing but 8. So we will be having 3 select lines, namely A, B, C. Based on this 0 0 0, D, if it is enable low, no, so it is 0, then this D0 is connected to the y underscore l. If it is 0, 0, 1, then D1 is connected to y underscore l. So at any point of time, only one input is connected to the output. 1-to-1 mapping. 1-to-1 mapping we will be calling as 1-to-1 mapping. Most of the times this is used for data transmission. One after another, one of the another data transmission will be using the multiplexer. So if you take the truth table into consideration, here the truth table you take the into consideration. See, basically if enable underscore L is 1 means inactive, low, active low. Active low means it should be 0. So if it is 1, whatever may be the inputs, your output will be, if this is active high now, output will be D0. Y underscore L, active low is 1. Because for active high, 1 is represented as active, 0 is inactive. For active high signals. For active low signals, 0 is represented as active and 1 is represented as inactive. So because we are having two outputs, y underscore L, that is why I am mentioning. Now, if at all enable is active, because active low no, enable is active 0, then if you give 0, 0, 1, then output is nothing but a D0. If you give 0, 0, 1, 0, 0, 1, then output is nothing but D1. If you give 0, 1, 0, output is D2. Likewise, based on the select lines, 1-to-1 mapping is done. Based on the select lines, 1-to-1 mapping is done. So for this, we will be writing the VHDL code and also the truth table, and then we will be implementing in xilinx software. So now go with the multiplexer. As usual, we will be using library IEEE. In that library, using the package called IEEE.std_logic_1164.org. So here the part is library and package we are using. Now we go with the entity mux 151 because it is a 74x 151 is nothing but 8/1 mux. We are writing input. We are having I. std_logic_7 down to 0. So we are having 8 input lines. 8 input lines. Next, select lines S 2 down to 0. 3 data select lines we are having. Then enable low we are having. Enable low is std_logic. This is also input. One enable input we are taking. And output we are taking y as out std_logic. Now we will be closing it. If you want to take, you can also take y underscore L out std_logic. We can also take, but I am not taking that one because I don't want to complicate the programming. Simply I am taking y output. Active high I have taken output because inputs also we have taken active high only. Now you go with the architecture name mux 151 of mux 151 is begin process. Here I already told you in the sensitivity list. In the sensitivity list it will be having inputs. What are the inputs we are having? I is one of the input. Select lines, enable input we are having. We will be beginning the case. So in order to make a multiplexer active, always remember enable should be active low. So E underscore here it is written as 0. If it is 1, obviously entire multiplexer will not start functioning. Once it is 0 only, the multiplexer starts. Now we are using the case statement. Case S switch select line. Select line we have taken S as a selector. Case S is when this select line S is nothing but select line. Data select line S is a 3-bit data, no? 0, 0, 0. Then Y is directly related to D0, which we have represented as I0. When 0, 0, 1, then Y is directly represented to D1. 0 1 0, y is represented to D2. 0 1 1, y is represented to D3. 1 0 0, D4. So directly we are assigning select lines from 0 0 0 to 1 1 1, from D0 to D7. When others, it will be providing null. That means it will be returning 0. Else y will be 0. If these are not the cases, then y will be 0. We will be ending the if statement, process statement, and we will be ending the architecture. Once again, I am clearly mentioning, you remember, here we are using the case statement, and here in that S as a select line. Case SL, when the select line is 0 0 0, y is connected to D0, which is nothing but I0 in our programming. When the select line is 0 0 0 1, this one is connected to D1. Likewise, based on the select line, your I will be connected to one of the inputs. Now we will be executing that in the this code in the xilinx software. We'll execute the code in xilinx software. Let me see. Now you can see here the code which I have written. You can see exactly we have written as input sound down to 0. We are having 8 inputs and we are having 3 data select lines. One enable input is there and one output we have taken. And as a selector, when select line is 0 0, this y is connected to D0 to D7. So you just see the case statement. When select line is 0 0 0, output is connected to D0, D1, D2, D3, D4, D5. Likewise, based on the select line, it is connected. Now, if we execute it, what happens? Now you see, we have taken one data. The data is what we have taken? Taken as 0, 1, 0, 1, 0, 1, 0, 1. This is data we have taken. So, see at 0, 0, 0, y is becoming active because 0, 0, 0. This is 0th bit. At 0th bit, we are having 1. Now, at 0, 1, 1, it is not active. Why not is 0? Because here, if you see, 1, 0, 1, 0, 1, 0, 1, 1, 0. You reversely see 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. So, at 0, 0, 0, y01 will be active. At 0, 0, 1, y will be inactive. So no, it will not connect to 1 bit. At 0, 1, 0, it will be connected to 2nd bit. At 3rd bit, it will be not connected. At 4th bit. How it will be? If you take a rotary switch, this is the output line. This is the output line. This is a rotary switch. We are having outputs as 0, 1, 2, 3, 4, 5, 6, 7. So this one will be, first one it will be connected 0. Because it is 1, it is active, data is transmitted. And second instance it will be going to 1, but there is no data, it will be returning 0. At third instance it will be going to this one, this will be shifted. It shifts to 2nd bit. We are having output is active. So data is transmitted from input to output. So likewise, the clock cycle repeats, data is transmitted. like a rotary switch, this multiplexer works. Most of the times the telecom department uses multiplexing concept. So I hope you understand the multiplexer 7 4x 151. If you are having any doubts, please ask me in next class. Thank you.